Intro music. Dooby dooby doo be doo. Dooby dooby doo be doo. Dooby dooby doo be dooby doo. Yay! That's working. That's working. There you go. There's your intro music. Hey, you get everything on this channel. Welcome to the Programming Games Club. My name's Blades, and I'm just a cantankerous old git. Hi. Welcome. What's the title for today's stream? It's the Vulkan Vertex buffer. Ah. Yeah, we were talking about buffers, weren't we? It was over here somewhere. Here we go. Things we need to know. Things we need to know. So we'll let the stream get settled just a slight bit. I think we should start this up actually. Oh yeah, I'm happy. Poppy's happy. Now, we did discover yesterday, well, I talked about yesterday, I don't know about discovered yesterday, I think I discovered it a few years ago, that buffers you can't program. It's got nothing to do with programming. So what the heck is this doing in the Programming Games Club? The Vulkan Vertex buffer. Why are we going to be talking about this, and shall we say designing it? Yeah, I think we'll say designing it. Designing our Vertex buffer today. We need to do this. We don't have a choice any longer, because I am heading to our first 3D program with graphics very quickly next week. We're going to actually be programming our first world. Not the third world, but our first world. Oh, my sarcasm's still coming through from yesterday. I'm way too happy. Hiya viewer. Good to see you. Thanks for joining us. You're welcome, and you are valued. Yes, that's the word. So, Vulkan Vertex buffer. Keynote. Remember, we can't program buffers, but we do need to know what programming is. I'm going to put an attempt, because this is the truth. I'm going to be very, very truthful with people in this series, and I'm going to use the correct words. It is an attempt to control the state. Anybody who knows about state machines knows what that means. If you don't know about state machines, I will do a talk about it if you want me to. To control the state of memory. Notice I haven't said program memory. Alright? Programming is an attempt to control the state of memory. It manipulates data. Data is stored in memory. We can manipulate that data and we can store our results in memory or act upon the results of that manipulation. That's programming in a nutshell. Why does that matter right now? It matters because of what we're about to do. We are about to define a vertex buffer. But we need to know something about programming. Because the act of programming itself causes it's known in the industry as side effects, and I think that's a very aptly named. And it's the side effects that make programs work. Most side effects from programming are intentional, like changing the color of your screen. That is a side effect. Any time you change data in your memory, you have caused a side effect. You have no idea on your operating system who, what, where and when is accessing that memory. And now we have entered programming hell. How does this look in a program? We've got a couple of functions we can look at, have we? I hope. To explain, any time, well, this has been known about for a long, long time, so I'll do a bit of a history piece whilst we're going through here as well. Well, actually more than a long, long time. It was discovered in C. As we moved on to C++. So let's have a look at, not this. That was me reading up on Vulkan a bit earlier. Okay. Oh, that goes straight to there now, does it? I'll cancel that. Let's have a look in Midnight. Midnight's got some files. We can get rid of the double screen. We'll just take a source file. Utilities is a good one. No, it's not. Is this a good one to look at? This is a good one. Right, what is a side effect? A side effect is when a function alters memory, intentionally or unintentionally. The act of having a program alters memory. Your program is stored in memory. Your program can have bugs because you may unintentionally alter your own memory where the program's stored. Think about that one. This has no side effects. This is called a pure function. At no point in that function is any memory written to. This is a straightforward function call. This is functional programming. If you want to know more about functional programming, visit a language called F#. F# is, F. F was created, Microsoft created F#. It was to go alongside C#, as C# is object orientated, whereas F# is functional. Is a pure functional language. Register output. There we go. There's a side effect. We don't know what happens to result after we've returned it. We don't know the memory location of result, but we have assigned, and this bracket here is trying to stop that memory location leaking out into the system by trying to clean it up and destroy it. It will actually destroy that variable result. And that's why C++ has brackets. They're not just scopes, which is what we use them for. That has function, a hidden function. So, understand that about programming. Whilst this is running, that is live. And this is running for 20... 80. Oh. A lot. We'll give that 250. So 2080, 330. We've got a check here. That's another 40. 370. We've got a return value. 300. We'll give that a 10. 380. And a bracket. So that'll be a 20 as well, won't it? 400 milliseconds. No, nanoseconds. Sorry. For 400 nanoseconds, there is a piece of memory on our machine that has been altered. What does that mean for the rest of the machine? Remember, our operating system is running 50... No, it's about 500,000 lines of code. Do you think in those 400 nanoseconds, plus the interrupts from the operating system, which we haven't included, do you think that piece of memory is external to our program is accessed? Well, it is. It actually is accessed, and that's a guaranteed. result from 400 nanoseconds. It has to be accessed. The lifetime of a memory cell isn't that long, usually. I don't know about modern day machines, but they used to be very short. They were about 80 to 90 nanoseconds before they had to be refreshed by the operating system. The operating system has to refresh your memory because the memory relies on a capacitor for that memory location, and that capacitor dissipates over time, so it has to be refreshed. You will hear about refresh rates. Hey, Rede Dutch. No, I don't. Hello, Aries. Sorry, I don't speak Dutch. I could do if you want me to. I can do double Dutch very easily. I think I'm trying to now. So the operating system is refreshing your memory. Therefore, that memory that you have put called result, that memory location, is being accessed as we are using it by another program. And that's why we have side effects. We don't know what the behavior result from that other program is. It's called, in programming, it's called undefined behavior. We have no idea. We're not controlling that. This is nothing to do with us. It's all to do with the operating system. Most bugs in programs are the result of external programs accessing the same thing that you're accessing. Will the operating system protect you against this? No. Does the operating system tell you it's doing this? No. Do computer programming courses teach you this? No. It was swept under the carpet in the 1980s, around about 1986 actually, as irrelevant. Yeah, bugs are irrelevant. That's basically what they said. Hey guys, you're programming away, you're creating bugs, and please stop doing that. Get this mouse out of the way. You're creating bugs galore. Don't worry about it, they're irrelevant. The operating system will take care of it. No, it won't. The operating system doesn't care. Doesn't do a damn thing about it. Your program crashes. Or in the case of nearly every single MMO I've ever played as a game, I've fallen through the floor. Because a pixel was missing. One single pixel, and I stepped on that pixel. And there was nothing there to hold me in the physics engine, and I fell through the floor. That pixel should have been there, but something somewhere has set it to null. To nothing. The programmer didn't do that. If they did, they were a bloody idiot. Or just trying to test my patience, one of the two, I don't know which. So, we know the side effects. The language F, or F-sharp, depending on which version you want to use, there's actually quite a lot of different functional languages. Attempts to get around this problem by using something called pure functions. A pure function does not have side effects. That there is a pure function. I'm using the wrong mouse again, damn it. This here is a pure function. This here is an impure function. It's also worse than it is actually a fully impure function, that, because it returns a result. That result is then copied to another it's shallow copied in the stack as it's returned as a value back to whoever's calling it. That's a shallow copy because the original copy is destroyed. Yet we can then use that result from this function to take an action, and that's probably what we are doing. But you can't, because it no longer actually exists. Do you get what I'm saying? In the terms of programming, returning that result, making that shallow copy, this no longer exists. It was killed here at the end of the function. And yet, we are using that value somewhere else in a program. Can we see the dangers of an impure function starting to occur already? Are you starting to understand what I'm talking about? That we are using memory indiscriminately, and it might not even exist. Exist in the terms that it may not exist within our program any longer. The memory, when it's destroyed, can be reclaimed. That variable memory location, when it's destroyed, can be reclaimed by the operating system to be used or assigned to another program. That memory has never been cleaned or wiped. That memory still holds that result. That's why we're allowed to do the shallow copy. That's why we are enabled to use that information on the other side from wherever that function was called from. We can do something with that value. Now, that means we've also passed that value via the operating system to God knows where. So there is an intentional, and it's not an or ever. I put or. That's wrong. Now, programming languages try to guard us against this and fail. And we have bugs. Because of this one simple fact. So let's get our eraser. That is a brush. And that's important. Now, we are going to be doing a buffer. A buffer is an area of memory. We can't program buffers because they are a static physical object. Blah blah. So what can we do with a buffer? We can define our buffer. That's all we can do. We can define what the data represents. So let's get there. Let's get to that stage and then we can get on with it. We can only define within our program what an area, now this is very, very important, an area of memory and this is the fiction of programming, means to us. And that equals a buffer. In programming terms, it's called a buffer. Right. So we now have our definitions. We now know what we're going to be doing. Do I need to learn Dutch, do you think? No. I'm not going to now learn another language at my age. We can only define within our program what an area of memory means to us. We are going to call this a buffer. We can't program it, we can only define it. You've already seen, or I think you're starting now to understand the bigger picture, the bigger problem, and why when applications and games are released to the public, they have bugs because of this one simple screen. And it's why I can hack any application. And there is no security they can present to me to stop me from doing it. But that's a different subject. Application security is a different. We're doing games, we don't need security, we discussed that. Let's get on with it. So let's define our buffer. It's a Vulkan Vertex buffer that we are designing. No, I'm not going to ignore side effects. This is a squiggly line, isn't it? Yes, that does mean something to me if it's squiggly. Right. Let's design it. There's no point in putting keyboard to programming a language at this point because we don't know what the design is. Interestingly, Qt, this is hilarious, converts between doesn't convert, but it can convert and is very easy to convert from OpenGL to Vulkan. So we can use the OpenGL standards, which is very, very lucky for us. I'll put it up here. Ass imp. The asset import library. This is been a standard for C since C really began. I think it's one of the very first 3D libraries that was devised, I guess. Is it good? Does it have bugs? It has bugs. Is it good? It's as good as you're going to get in the form of a library that hasn't got gold code in it. It's close. It's pretty good. But I don't care about that. I just want a functionality. We are not going to be putting async into our library, our static library. There's no way I want that trash code in there. Under any circumstances. Qt already has async embedded within it. I'm not going to make the same mistake. We can't use Qt's async, embedded async, directly. We could use Qt 3D and then slot a Vulkan backend on it. We could use Qt OpenGL and convert to Vulkan. Or we could use Qt Vulkan and do it ourselves. As this is a club format where you can chip in at any time you wish, I think I'll do it ourselves. But we're going to do it in the professional fashion, not the amateur, oh, here's a video on how you load a 3D model, which is the stuff that I've been allowed to give away previously, although I have touched on the industry standard, and we will possibly improve on that. I wonder. I don't know. So, Asimp is a library. You can download it from GitHub, or you could go to Asimp, I suppose. So let's have a look. Asimp, where are you? You're here. There's a GitHub. There's documentation. Here we go, Asimp. So, introduction, installation. There's no way in hell that I will ever use Asimp on Windows. If you wish to use Asimp on Windows, feel free. Just don't ask me to. I will only use Asimp on Linux. Why? Browse, please. Yeah, search. Wrong key. I am going to go shopping soon and get these keyboards sorted out. It's starting to really annoy me. I need a keyboard extension holder for the desk, and have a second keyboard that I can just slide across in front of me instead of picking it up off the floor. Yeah. There we go. Right, hit return. So, library to import various well-known 3D model formats in a uniform manner. We have portable open source library to import various well-known 3D model formats. Yeah. There's two versions. This one is from the AUR, which is not part of my Linux distribution. The AUR is, or can be, a dangerous place to go for things. I don't normally go there. The only reason I have it is because I'm using Gitkraken, which I do trust. You must trust and research things before you take it off the AUR. So we have .NET. So that's the .NET wrapper for Windows. What else have we got here? We have the lib32. Okay, get rid of this mouse. I've had enough of it flashing the bottom line off now. What else we got here? We have the lib32, yeah. Asimp Git from the AUR. Asimp Net from the AUR. We have the MinGWW64 Asimp. That again is Windows. If you remember rightly, we were having problems because we're using GCC here and we're using MinGW on the Windows side for compiling there. We have Python 2. We have Python. And we have Doomsday. which is a Doom engine. You know what Doom is, don't you? It's a famous game written in Doom was written pre-graphics card, which we could do as well. Hadn't thought about that. No, we've got Vulkan. We'll use the graphics card if it's available, and if it isn't, we'll use the CPU as our graphics card. We don't care. So I just want ASIMP. Just the official repository. So there's quite a lot here. I don't know why they've got Python now. What a waste of time. Who would want to do 3D programming in Python? Oh yes, somebody who's stupid. Yes, I remember now. Okay. Oh, by the way, Python is a very, very, very good language. Just so you don't get me wrong on what I just said. If anybody wants to learn to program the basics, how to program, investigate things like side effects and how programs develop bugs, Python's probably a very, very good language for it. There we go. To install, just apply it. The other thing I didn't mention about side effects is if you have decided to use a garbage collected language like C# or Java, then you're in for a bad time. It's why I will not program anything more than simple applications in those languages. It's not because I don't like the languages, it's because trying to handle the side effects is impossible. You can't. It's got a garbage collector. The garbage collector is there to do it for you. And let's just say that the people who programmed those garbage collectors were people who were born or learnt programming after the side effects issue was swept under the carpet. Not by people who learnt to program with side effects. And there are two separate, distinct groups of programmers there. And it's huge. The disparity is huge. Oh, we have it. Cool. We have ASIMP. Right, so we have ASIMP available to us. Okay. And that's why I'm using Linux, because that's all I had to do. I'm not going to show how to do it on Windows. I do know how to do it, and I have done it in the past. I have used ASIMP from within Visual Studio 2019 and 2022, whatever it is now. The most modern-ish one. Okay, installation, Microsoft Compiler and C++. Oh, God help you. So, usage. Here we go. It starts with AI scene. Notice how we have an ECS system that starts with scene. We have the import file. We can set that up and it creates a tree of buffers which we can read into our memory in the format that we wish. There is a node hierarchy, as can be seen here. So, what do we have? We have an AI node, meshes, transformations, children. A model can have children, things. Models, 3D models can become very, very complicated. We can get the meshes, the materials, the bones. That's going to be very important. Bones are for animation. It's an animation style which has been used successfully, and it works. So obviously bones leads on to animations, textures, and that's it. Each of these areas are huge. So let's simplify this down and look at it in the form of a program, because reading through all of this garbage is going to take us all day. Actually, I should have kept that open. Do I need to? Yes, I do. Let's go to GitHub. Let's find a piece of async programming. I am really getting fed up with this keyboard situation. I find it very, very difficult to type, if you don't know. And having two keyboards is making it even more difficult. So let's pop over to GitHub and see what we can find, shall we? Good. Sunrogue. This is mine? Yeah. It's in C. Async is in C, but you can use it in C++, that's not a problem. Okay. Let's just have a quick look through here. We've got some C program. Alright, we have a loader here somewhere. Here we go. So this is using okay, nothing much in that file. How do we get out of this file? Okay. And here's the hash include load model 3d.h. Okay. Load model 3D. Blah 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 blah. Load asset, VAOID, num indices. Yeah. We haven't even discussed the vertex yet, have we? Where's the construct for this? Where's the async construct? Allocating. Here you go. There it is. So, we have a C struct, AI scene, called scene. The AI scene is from the asset import library. We set it to null, and then we try to import the file from the path using the AI, or the asset import library, process preset target real-time quality. The quality that you use is your own preference. You need to look them up and decide, well, we will need to look them up and decide what we want to do. If the scene doesn't happen, it'll return null, and we've got an assert here to crash the program and say, hey guys, this ain't working. Notice we have color, we have storage for the vertex array, that's a buffer, We have storage for the vertex buffer object itself. And that's just memory allocation. This is setting up our area within memory to hold these buffers. Well, to hold that VBO anyway. Alright, so that's your constructor. This whole thing's constructor. Alright. So, in the old style, well, I'm going to call it the old style of OpenGL. We set up our vertex array object. So it's an OpenGL uint, unsigned integer. It's a buffer, and we start it as false because it doesn't exist. We then we ask our graphics card to remember this is from the graphic. This is held on your graphics card. GLGen vertex arrays. It's the driver for OpenGL will only hold a pointer to OpenGL on your graphics card. So that function is in your graphics card, people. You need to have either an SDK or the OpenGL driver on your machine to be able to access it, because each graphics card may have it held in a different place, at a different memory address within its pool of buffers. So that's why this is got GL in front of it. GL means OpenGL, but it also means function on your graphics card. So we are appending our vector storage with our buffer. So we are saving. What are we saving here? We are saving that, which is an uint. So we are saving a number from 0 to however many billions actually for a uint. Because our graphics card doesn't give back the memory location. It says, I'll keep hold of that memory location for you, and I'll put it in a table, and we'll hold that here on the graphics card, and the index in that table is a number. It is the position within that table that you will want to use to access that buffer. So it gives us a handle. In this case, it would probably be 1, as it would be the first thing that we created. Okay. So indices. We now need to work out how many of these vertexes, which we haven't described yet, how many of these vertexes we need. You can already see that I've got this problem in the back of my mind. So I've actually put some notes in here. Wow, I'm doing good today. So you can follow this through, and you can see that we pick up how many indices there are. And we've got face indices, gen buffers, index buffer. We store it obviously for later use. We bind the buffer, the data. We define the data. Look how we're defining data though. We're telling the graphics card that it's going to be an array of elements, as all index buffers are in OpenGL. It's the size of a uint in bytes, and it depends on how many faces we've got, and times 3, which is times 3 for a triangle. Because OpenGL deals in triangles. Well, we have set it to, it defaults to using triangles. It can use quads. We're not using quads. So we now have we now know the number of vertices we have. No, we now know the index number, which can be a lot bigger than the number of vertices. Vertices can be used multiple times. The index, so if you have, for a cube, you have 4, 5, 6, 7, 8. You have 8 vertices. You will have 32 indices because those vertices have to be used multiple times. You only need to use those vertices one set of times. I think it's 12, is it the minimum? Yeah, 12. To actually draw a cube, you only need 12 indices. If you want to draw a cube properly and use lighting effects on it, you have to do it 36 times because you have to duplicate all of the vertices because they need to face different directions. That'll become evident in a bit. If they don't face different directions, when you do your lighting calculations, they'll all be facing the same way, and your light will flatten your object and make it look 2D. So don't be lazy on your vertices and your indices. That's why we have indices, so that we can use vertices multiple times, but we only have to define them once. Now in OpenGL, our vertices are coming in as positions here. I can tell that because that 3. That 3 tells me that these vertices are positions. Okay. So we're transferring a buffer, a vertex buffer, which again is a uint, it's a number, it's the third one we've made, so this will probably be the number 2. We bind it so that we can affect it and use it. In other words, the graphics card says, hey, which buffer do you want to use? And we say, oh, we want to use this one. So we bind, it's called binding. We want to use this one. We can only operate on one buffer at a time. This again is to try and prevent side effects, interestingly enough. Because OpenGL is a state machine, it's very good at limiting side effects. Okay, we enable. Okay, we then load in colors. Colors are 4 floats, RGBA. I can tell that because of that 4 there in the attributes. So it doesn't just tell the graphics card how these work. It also tells me as a programmer, or my sort of programming self, what this data is. We also have normals. Normals are which way is the vertex facing. Again, it faces in 3 numbers. Those 3 numbers are a vector in space. A vector in space is a length. It's a vector. A vector in space is... it's a length, a magnitude, a length is called the magnitude, and direction. So it assumes a point in space, and then it will go so many in the x direction, so many in the y direction, so many in the z direction. Wherever that point in space results, it will go from the origin to that point in space. That creates a vector with a line, and you should put a little arrow on it. So you've got your magnitude and your direction. So that's what that is. Okay. We are then using the vertex array object ID buffer. We are setting our loaded assets. We have a loaded assets. Who's defining that? It's defined somewhere. It's a structure. It's a struct. I don't even need to look it up to know that. I can tell because of the way it's being used. That's a struct. So I'll find that in the struct files for C. Whatever I've programmed into those structure files, we'll find something called a loaded asset, which we've made a pointer to, which is our memory, our buffer, and we're transferring all the details. We can release that now and destroy it because we've loaded it. We can free up the memory, freeing up memory, and we just return our structure full of all the data. Lovely. That's how you use the async. All done for you. Ain't that cute? That was done on the 26th of July 2020. Interesting. 1.5 years ago. No, yeah. 1 3/4 years ago now. Wow. Time flies. So that's how we're going to load something in async. I think that's fair enough. But I've been talking now about indexes, vertex buffer, color, there's something missing here, isn't there? We've got vertices, we've got colours, we've got the normals. Where's the textures? Aren't the textures held in the MTL file? But we haven't got the UVs on here. So this hasn't got the texture system in it. This will load a colour model, 3D model, not a textured 3D model. But we have some starting information. We have quite a lot of starting information here. In fact, we have a smorgasbord of information which we can now use to help us develop our system, our new system, our brand spanking fantastic first pass of garbage code. Remember, your first pass with any code is going to be garbage. Doesn't matter how good you want it to be or how careful you are at programming it. So don't try and be perfect first time. You will fail, especially in programming. And never pretend you know what you're doing. I certainly don't. In fact, I declare that I don't know what I'm doing. I'm just looking at that screen now, thinking on how I can help you understand the process which I'm going to go through. I want to show the process more than the code. This is a games club on how to write games. It's not... it is about programming, I suppose. I want this to be more information. If you want more programming, then ask me to do more programming. Tell me what programming you want. I'll do it for you. Program anything you want, I don't care. But whilst I've got no requests coming through for programming, I'm gonna happily develop this buffer system. Why don't I have a fully featured one here? Doesn't matter. It doesn't matter at this point in time. Okay. Dude, you stay there for a second. So, let's get back to the top. Luckily, I've put notes in here. Alright, I'm going to skip the VAO buffer because that's got nothing to do with a vertex. The indices have nothing to do with a vertex. We are doing vertex buffer design, not index buffer design. They are two separate buffers. So let's do the vertex one first. We'll do the index one after. So that's your index. Here we go, vertices. I've called this a vertex buffer. It's not, it's a position buffer. What is a vertex? Now, unfortunately, you're probably being taught, or you've got the idea that a vertex is a position. No, it isn't. A vertex holds a position, but a vertex is a damn sight more complicated than a position. A point in 3D space means nothing to a computer. We have to know that from the start. We need to know everything about that point in space. So a vertex is the description of that point in space. So yes, it has a position. That's bloody obvious. It's the rest that probably isn't. We'll use the bracket notation because I think that's pretty standard. So we know it holds a position. That's what everybody thinks a vertex is. It isn't, but hey ho. Which one do I want? I want that one. Okay, so we've got a position. Colour. It's not going to be called colour. Let's just get that right. We are going to call it material. We'll spell it the American way. Texture, reflection, reflectivity. I'm running out of space. Dot, dot, dot. It continues and continues, so we'll just skip that, shall we? We'll come back to that. That's a whole new ball game. So I've got a material. Let's go back, see what else we've got here. So well, in this program it's called colours. Yeah. Which is why I said, maybe we want textures as well. Normals. Oh, that's not part of the material. We have to discuss all of these and define them. Okay, normals. Yep, that's right. And that's it. Interesting. I'm happy with that result. Shall we take that as our base vertex and leave it there? This is a lot of information, isn't there, when you look at that? So position is X, Y, and Z. Normals are X, Y, and Z. That is a point. That is a vector. Mathematical vector, not a programmatical vector. Programmatical vectors are storage classes. A mathematical vector is a magnitude and a direction. Right. Okay. Is there anything else? Well, yes. But let's not go there. So a vertex is very complicated. A vertex is a set of data that describes everything about one point in space. Let's put that definition in. So so it defines all data to describe a single, never get this wrong, a single point in space. For us, we're going to go 3D. It can be 2D. It can be 2.5D. It can be 1D. It can be 4D. It can be anything you bloody well like. We're going to choose 3D. So we now know what a vertex is. It isn't a position at all. There's a hell of a lot more to it than just a position. One of the biggest problems we have, well, no, we don't have one of the biggest solutions we're going to have to come up with is the material. The position and the normals I can do straight off. The material we're going to have to be careful with. We can choose colour and texture. Don't know. Maybe we should do them all. Maybe we should do them all. Should we find out how many there are? You're gonna love this one. Well, peek into materials for a couple of seconds. We're not going to go there probably today. We will be going there next week. Let's go for an industry standard, the OBJ model format. Yeah, we'll go for that. Let's pop that on screen, shall we? Dot OBJ. Let's have a wiki for that, please. There you go, wavefront. .obj file. It's just a standard. Basic materials. Okay. So, coloured. We've got diffuse, specular, transparent. So colour is split down. Optical density. Ambient, highlight, reflection, transparency. Shadow. Casting. In other words, is it solid or not? The textures, we have an ambient texture, a diffuse texture, a colour texture, a highlight texture, the alpha texture map, which is how see-through something is. I think that's the best way of defining alpha. Implementation of the bump map. To make a texture look more 3D. Bump maps we're going to use. Definitely. Luminance. Does the texture emit light? Light bulbs do. Interesting. Displacement map. Sometimes called a height map, I think. And of course stencil maps. Stencil mapping is used. Think of stencils in real life. What do you do with a stencil in real life? You can place it down and it will be a piece of cardboard, say, with a shape cut out. You can place it on a piece of white paper and then paint in the gap. Take the stencil away, and you get that paint on your paper in that shape. Stencils work in the same way well, they don't work in the same way. Stencils are used for that kind of effect within textures. I think that's the best way of putting it. So reflection mapping spherical or from origin ambient, yeah. There are options for your textures within those maps. This is the simplest format. And you will find all of this information in the MTL file. We didn't put one in, did we? No, we haven't got one. We haven't even got a 3D model. Okay. So the information about the geometry, in other words the position, includes vertexes, how vertexes are grouped up together into faces or triangles, the indices, which we're not dealing with currently, the texture coordinates, how textures are coordinated onto those faces, vertex normals, as we've already said, usually used for lighting, but can be used for other things, as they are a vector of where the vertex is facing. Line elements if you want to draw lines. There are other geometry formats, great. And then, of course, we get to the MTL lib, which is the MTL file, which is given out by an OBJ. We don't have any on this computer. What does an OBJ file look like in reality? Oh, why did that happen? Let's see if we can find one. I've got resources here. Here's an OBJ. Where's player? I see how they have an MTL file. So let's have a look at one of these MTL files, I guess. So materials, I'm just dipping into it, by the way. We'll look at the letter A. There you go. No information on it because I didn't want any. I didn't want a material on it. I wanted it as a blank, basically, so I could do what the hell I liked with it. So I don't think any of these MTL files have anything in. What they are showing is NS, KA, KD, KS, D1, Illum2. That's your illumination. I think that's how much light it gives out. NS is specular. KA is your alpha. KD is your diffuse colour. No, KS is specular. What is NS? Roughness? Surface scattering? I think it's your surface roughness. Don't quote me on that. I'm not looking at the wiki right now. I don't keep this in my head. I just look and try and interpret. I've forgotten what D is, but it was very important. Tough on that one. Look it up. You can also see that these are all MTLs. So the objects have been taken out of this file. Where are the objects? Je ne comprends pas. Okay, whatever. There aren't any 3D objects in there. There's your shaders. I didn't put any in there. Okay. Oh, that was clever of me. So, Amber Sky's Rogue. Oops. Ah, here we go. Player. So, the actual OBJ is just all the coordinates for the vertex. These are the points, the position. Starts with a V. Very easy to work out. What the hell is this model? This is Suzanne. The monkey head out of Blender. These are your texture coordinates for each face. Each face is a 2D plane, so it only needs two dimensions for each face. So this is the position upon that face of where a certain, well, it will work out the pixels from the texture and transfer them to the coordinates defined by the texture coordinates. There will be 2 texture coordinates per vertex. Sort of. Never mind. Yeah, there'll be 2 texture coordinates per vertex, and they map onto the face, the triangle that is made by 3 vertices. So there's your textures. UVs they're called because X, Y, Z is for the vertex. What comes before that? U, V, W, X, Y, Z. So they use U and V. Other systems, mathematical systems, will use S and T. Yeah, I think they do actually. Depends on the mathematical equation system that you're using for maths. We're not doing maths. You don't need to do maths to do programming. That's a fiction. Alright, so we're coming down to the end of the texture coordinates. We now have the normals, which are the direction in which each vertex is facing. And here we go, off. And then we have a list of all the faces, which are groups of 3 vertices, and each vertices has its vertex as the first number. The next number will be its UV, I think. Don't quote me on this, I'm not sure, not without looking it up. And the last number is going to be a normal. So, and these are in the format of an array. So it's the 35th vertex. 1, 2, 3, 4. Yeah, you get the idea. It's the 35th vertex, whatever the 3 numbers are. The first, whatever I call that thing, UV, set of numbers, and the first normal set of numbers, kind of thing. So that will give you the information for that vertex. So basically this is just using it's not using material. You see, use material none here is a command. Or, well, no, it's not a command. It's a note saying don't bother trying to find the material because we're not using one on this. I didn't want to use one on this. I wanted to design my own material system. And then it'll go through all the faces. And each of these faces gives these, but you can see how all of the numbers are muddled up for each face. Each face that joins onto the, like that face joins onto this face, joins onto that face, joins onto that face. All the faces are actually in order. We've got an S1. No idea why that's there. That could be a bug. I'd have to look it up. Hold on a minute. S1, that's a marker. So that's S0. Attached to S0 is another model, S1. There will be another model yet, because there's ears. If I remember right, I think the ears are separate on this model. Or just attached. Something like that, or it's the eyes. No, it's just split in two. Symmetry, maybe. So is this a reflection of your first data? Could be. No idea how I'd find out. I'd have to look what S1 means. Which I'm not doing now, I'm just showing you how the data looks. That data is completely useless to us. Asimp will import that data, sort it all out for us into a useful format. It will load up an OBJ file. It'll load up quite a few different things if I remember rightly. We'll see. We've dealt with that. Okay. I'm not happy about this file. I think we may have to rewrite this. Yeah, I'm up for rewriting it. It's got information, but I also now want to include materials. I want to expand upon this basic idea, principle of how to use... This is very simple, you must admit. How to use Asimp. Very, very simple. There's nothing complex here. All you're doing is you are transferring data from wherever Asimp stores it to the buffer on the graphics card. That's all you're doing. We don't want to do this though. We don't want to transfer it to our graphics card. We want to transfer it to our buffer system. Yeah, we're rewriting. Yeah, we're rewriting. Good. Don't want that page. That page is useless to me. I want that page. Installation usage. Access. Input output logic. Where's the information? Why is nothing happening? I want to know what it supports. Alright, we can do it this way. What do you support, dudes? Blender 3D importer. Does this work nowadays? It didn't used to. Use either rendering material, custom materials, see materials. Do not use flip up axis to Y. Yeah, okay. Use skeleton name, follow mesh, okay. You idiots. You absolute idiots. If you can't write an ECS by now, what the hell are you doing? Sorry. Alright, so we do have a class system. That's going to be useful. Here's the read file bit. That's obviously the big advantage of using this. Can read. So we do have a can read. So it's using a detection system to find out what type of file it's reading. So we don't need to worry about the type of file. Where are we in this system now? This is just a documentation. Okay. For software vulnerability information. Unity's in here, oh dear. So Wireshark is one of the sniffers used for, how can you put it? Hacking. Oh God, this is a long list. I don't want this. I want something. Let's go to the GitHub now. Here we go. Where to get help? BSD. Oh, that's fine. BSD is just do what you want with it. But if you do change the code within these files, please, please, please let them know what you've changed and why. It might help them get rid of some of the crap that they've done. Okay. Using the pre-built libraries with Visual Studio. Here we go. We can use 3MF, Collada. Collada is Blender. That's Blender. It's also one of the original. It's Collada and Blender. Really, you shouldn't be. Did Blender move away from it then? But we can use .blend, so we're going to have no problems. That's fantastic. We won't need to go into the OBS stuff, which is the initial, very, very first 3D format, really, that was developed, I suppose, by amateurs, or whatever you want to call those people. The first people, the frontier people who first came up with the ideas on how to start standardizing all of this information. Collada is what happened because there were all of these formats. So all of these formats, as in some way, developed either because of or from Collada. That's your base. OBJ is the base of Collada. Collada is the industry standard. Everything else comes from there. FBX is possibly one of the most usual. PLY, the Stanford Polygon Library, that is a learning standard for use with university courses. We've got anything else down here? Oh, we've got the MDs, have we? From Quake. Yeah, right. We've got the Doom engine. DirectX, of course, has to be in there because, well, DirectX is stupid. It's also probably one of the best rendering systems going, but it's also stupid. Quick 3D, that was pre-Qt. I think Quick came out before Qt did. The Qt ideology came from Quick. I might be wrong in that. Okay. Autodesk, yeah. Anything else in here that's actually there? Got Stanford PLY again. Just repeated. A 3D game studio model. So we can use any of these models that we can find or draw ourselves. I think that's where we're going to have to start, isn't it? We're going to have to start with a model. And we're going to have to work it from there. But we need the most complex model we can think of. It's going to have everything. That's going to be an interesting one to make. Remember, I know Blender exists. I have used Blender to make models. My 3D graphics capability is minimal. I think that's the best way of putting it. Let's just put it that way. Let's just say I'm not a graphics designer by heart. I love art. I love art. I did take art. I do have an O level in art. But I found the information I wanted. We've got all of this to go at. Lovely. That's what I wanted to know. Do I need to convert? No, I don't. Good. So async, we don't need to convert. We've decided what a vertex is now, and it's turned out to be this horrendously big data structure, which is why I'm not doing it from scratch, and I'm using async. Do we have anything on this board relating to yes, we do. I'm going to go and put the kettle on. Das Ketteleisen on. We're going to do some programming. You can't program buffers, so we're not going to do some programming. Oh my god, how do you explain this? Alright, we need to transfer ideas into a programming language. Bugger, we don't. We have to write an async model loader, but we need the buffers. We're going to have to do the buffers first. This is all in preparation for next week because we have to write that code to import and display. Our first project is going to be import and display on screen a model, whatever model we choose to start with. We'll probably choose one at random. Alright, here's my cup. Let's go make that coffee. Okay, what we're about to do has never been done before. Well, not in this format anyway. We've just gone past normality in the programming world and we are entering onto the frontiers. I'm sorry about this. Because every single program you look up on the internet has probably been designed, unless you can find one on the internet now that was designed pre-1986. Qt didn't exist then. So we've got nothing. We have nothing to go on. There we go. Position material normals. Okay, let's get that programmed. Ha! You can't program it. Jesus. I'm loving this. Alrighty, give me QT. Okay, we'll close that. We'll go for Vulkan. We're on main. We do have a window. What have we got? FPS isn't linked. I thought I did that. Yes, I did. Thank you. 93. Exit button. Window. Vulkan's working. Vulkan render in. Yeah, it's active, which means the background changes colour. Good. Exit. We have Vulkan. That's a good start. Source. GFX. Let's have a header file. Let's call it buffers. This is graphics buffers, isn't it? I might do some cleanup after this. Buffers. File name. Git. Yeah, okay. It's not a class. You can't program buffers, so don't make it a class. Okay, what have we got in here that we might need? Nothing. Okay. What we're going to do probably is, I'm just going to take this off the top of my head because I don't exactly know how I'm going to finish this. I'm going to type def struct. We can make it typ. Yeah, okay, alright. You're complaining at me already for bad typing. Type def struct. We can call it. Yeah, we're going to call this GFX buffer. How about that? It's going to need position, material, and what else did I say? This is how good my memory isn't. This is why I have notes. Normals, position, normals, material. Position, material, normals. I'm going to put normals next, and then materials. Normal, plural. Yes, they are. Material. Okay, so that's everything there. Type def requires a name. Alright, wrong. Get rid of that. Let's pop you in here. There you go. Shush now. Don't complain at me. I'm having a good day. So there you go. You can't program a buffer. That's as much as I can really do. So now it's going to get confusing because we're about to use something that looks like something else. Let's include Q vector. I want the 3D version, please. Not Q vector. Note, Q vector is a storage device for a vector storage box where you can push back more and more things and store a long list of items within it. Q vector 3D, however, is mathematical. It's an actual mathematical storage device for not 3D, but for 3 floats in a row. That's the best way of putting it. Position. We should give it a blank. We'll think about that. Okay, so we've done that one. Normals are Q vector 3D. Is it 3D? It is now. Normal. So it's got a position, it's got a direction it faces. The direction, the okay, this is a vertex buffer, isn't it? The direction in which a vertex faces. Now, if, this is a problem, especially in the human mind, that a point in space can face a direction because a point in space doesn't have a surface. Yeah. It's a mathematical, theoretical idea. Okay. I'm getting rid of that S. The material is here. I'm doing this in C, sorry. GFX, we're going to call this material. Okay. I'm writing in C again. Why? Don't know. Various attributes. Let's start with color. maybe. Color would be a Q vector 3D, 4D. I don't pretend to hate 4 dimensions. Can we have a 4D? Yes, we can. So we can have a Q vector 4D color. We don't need anything else there, do we? The reason a color is 4D is it has red, green, blue, RGB, and an alpha. It's see-through ability. Okay. So that's why it's 4 and not 3. It's got nothing to do with maths. It's just the way that we are going to store and represent our data so that we can place it into a buffer. Or place it into memory in a certain format, and that's going to be the biggest part. Structuring that memory. These are just holders. This is just a holding zone. Okay? This, we're not going to have, if there are 1,000 vertexes in a model, we are not going to have 1,000 vertex buffers. We are not going to have 1,000 materials. We're going to have 1 material and 1 vertex buffer, probably. There may be multiple materials, I suppose. You've got to remember, every single vertex could have a different material. Put that into your mind and think about it. An interesting fact about that is you could fix one of the vertexes in space and make all the rest mobile. Or relative, which is how it actually works. That's how the mathematics works behind the scenes. We're not interested in that. We're not doing a maths course. So now we have that. You're probably thinking now, why didn't you do this first? Because you needed to know why I was doing this. And you also need to know why half of this is probably going to get rewritten straight away. As we hit the problem straight away. Side effects. You have to program with the knowledge that what you are programming won't work. When it comes to buffers. And that's a bit awkward for a programmer. A real programmer, anyway. It's not awkward for me. I don't give a dingoes whether it works or not. I know that I can produce gold code which will always work and will not give bugs. But I've already told you that's impossible to do. Yeah. This is going to be a fun part in these game programming streams, I think. Oh, talking about game programming streams. I haven't updated. Let's do that whilst we're here and I'm thinking about it. Where are we up to? We are up to you. Are you part of this yet? No, you're not. Okay, you are now. So we've got part 2 there. For the widgets. Okay. I'm not overly bothered about presentation or trying to look professional. People are starting to watch this. That's interesting. For you people who are starting to watch this, if you would like to give comments or if you want to request ideas or want to learn certain things, let me know. You can comment here on YouTube. I do receive notifications. You can join me here on Twitch when I'm broadcasting anytime you want. You're welcome. You please don't feel stupid about any question you ask, because as you are going to see, I'm going to look more stupid than any question you can ask. Trust me. I'm very good at making myself look stupid when I'm programming. Alright, so we're there. I'm not hiding anything in this series either, as you can see. That's part 2. That's what we're doing. Oh, we have got one. Item creation. Okay. That was really good, that one. There we go. That's going up as well now. So we are updating. I'm still on my coffee break, which is why I'm doing this. Before I put that last line of code on Qt. I know I haven't put it in yet, don't worry. Yesterday? Yeah, it was Friday, wasn't it? Yeah, Friday's stream was brilliant. Remarkably good. If you haven't seen that stream, go watch it. It's the one previous to this. Oh my god, I don't know which plane of existence I woke up on, but that stream is just pure gold. I just did a self-advertisement. Oh dear. Alright, that will do itself. That will update for you now. By the time this has worked out what the hell yesterday's video was, it'll be up on YouTube. Good. Done. Next. Let's get back to that line of code. So remember, this is pass 1. Various attributes. We need to explain that line a little bit more. Color, texture, button maps. I'm going to put that in. Because it is a thing. What else can we have? Reflectivity. That's a big one that I want to keep in my head. There you go. I think that explains what this material thing will develop into. There we go. Developers required. Done. Oh, material. Here we are. And all we do is we slot our material in. So we have a GFX Vertex. And this is where the problem starts. Because we're about to do that. GFX material itself is a space in memory. Okay? It's within our area. It's our memory we are going to just treat as one big buffer. And within that big memory buffer, we are going to have this. Well, the programming language will place this, when created, into a memory location of size, whatever size this is. All of that we don't care about, because us programmers are, well, we just don't care, we just program. We're hackers. There you go, there's your GFX material. It's a type def, notice, so we can use it just like you can use int, float, things like that. Just like we can use Q vector 4D. This is a type def. So this is a type def struct, Q vector 4D, and then it just has X, Y, Z, alpha as its things, and they're all floats. So float X, Y, Z, alpha. So that there is exactly the same as one of these, but we didn't put a star in front of it because we want to hold those values within this memory area. The reason we want to do that is we don't want this to accidentally get mixed in to our vertex buffer when we are designing our buffer itself. We want to keep the position here. We want to keep the normal here, but this material is a complicated beast and can change. So we don't want to keep it here because that could alter the size of this structure. And this is where the bug comes in. Remember I said there was a side effect? If you run the program and material is X, or size 1, let's call it size 1, for the first time you run it. Later on you develop as required and material becomes size 52. What's the side effect? If I was to take that star off the beginning there, the side effect would be this would change size. If I develop here, this will change size, this will not because of that star. And that's why we use pointers, peeps. We can't have our vertex buffer changing size whimsically because it can. Because if it does that, it's going to use more memory. And who's been using that memory before? Whose memory was that we're suddenly growing into? What values are in there? What is that memory? If we start with a set size, we now have a chance. We can now control that memory. And this is where people have made their mistake. People who have learnt programming post 1980s don't know this. You make this mistake, you have a side effect within a structure, not a function. And this is why I was talking about side effects. This is why I went through all of this stuff to get us to this one line of code. And it's possibly the most simplest line of code you've ever seen. And it's the biggest bug in today's code. Modern programs get it wrong 90% of the time. Because programmers today do not understand the difference between a variable and a pointer. A pointer is a memory address. A variable is an alias, usually stored on the stack, not in memory, not out there on your computer. It's normally stored very close to the chip. Whilst the programming is running, the program will be assigned a space in a stack on the chip or near the chip or in special memory allocated to your CPU called the stack. There are two different parts in memory to each computer. That's how they're designed. That will be stored in the CPU. That will be stored in the computer's memory. And will need to be, it's slower because it needs to be called in and copied in when used to the CPU. The modern day CPUs will also assign a local stack variable to the value as well. And this is where the problems start. You can see it already, can't you? You can see what's happening now. That we are not managing this memory. Things are happening in the background that are making this memory into spaghetti. We have no chance of making this gold code, have we? And yet I just have. With one single asterisk. Yeah, that's gold code. You can't break what I've just put. You're probably thinking to yourselves, why don't you put these out there? Because these are never going to change. I could even put static in front of them to tell the CPU this is never going to change. Ring fence it, lock it down. These locations are going to be called position forever and a day. This is going to be called normal forever and a day whilst this program exists. That's what the word static should mean. It doesn't, but it should. So I'm not putting static in front of them. Right, we've programmed the buffers. That's what a programmer would say to you. We can now use them. So I've already done the impossible. But there is another thing as well. That you have to realise. That we now have a structure using two different memory types with one of our major items, the material, dangling out there in forever everland. Basically at the mercy of our operating system. It's our operating system that gives us that memory location, hands it to the program. We are now at the mercy of the operating system. Do you trust your operating system to manage that material and keep it spared from any monstrosities that it could create? No, DL is like, you don't trust your operating system as far as you could throw it. And as it's a virtual machine type thing, you can't throw it anywhere. Get it? Good job. that material is goosed. Completely goosed and useless. Using that material will cause every single known bug that you have ever seen in games where the graphics, especially because we're talking about graphics here, where the graphics don't seem to quite work the way you should do. You suddenly fall on a platformer, you'll suddenly fall through a platform unexpectedly, and it's not intentional. The programmer didn't mean that to happen, but it just happened. So not only did they not put an asterisk here, they probably also didn't realise the vulnerability of this piece of memory. This is high vulnerability. This is closed vulnerability. But as I've just said, we can't use closed vulnerability on the material because the material is of an unknown size. In fact, materials are probably generated on the fly and are of different sizes for each model. And for each material. How many different types of materials are there? Thong materials I've heard of. Should we have a look? Let's research that just a second as we're here. There's no harm in looking at things, is there? Let's go to Qt 3D. Okay. Could be something in here. So we have the abstract classes for different things. Don't be afraid to take ideas from other places, but be aware that when they programmed these, they may not have been programming it from the same viewpoint as yourself. Remember, programming is about your own personal viewpoint. There is no correct way of programming. There is no incorrect way of programming. There is just, well, a lot of pitfalls to try and avoid. We've got depth tests. We do have a Q material. I'm thinking extras. And this is Qt3 renderer, isn't it? Yeah. Do we have extras? There we go. Metal, rough material. Default implementation of PBR lighting. Morph Phong material. Default implementation of the Phong lighting effect. So those are the two that it gives here. How many more are there? Well, as many as you can invent, is the answer to that one. So our materials aren't fixed. Just like our geometry isn't fixed. How many vertexes are in the model? How many indices are there in the model? Each model is different. And this is where the buffer system falls to pieces. Literally falls to pieces. Is there a better way of doing it? Are buffers really the answer to all of this? Well, the answer is yes. Of course they are. But Not as we understand buffers as programmers. We have to understand buffers as I've described an area of memory. We have to look at them as an object, a real physical object, rather than something we can program. And we are going down that route now. So there you go. Just wanted to show you that. Thought that was interesting. It's already within Qt. Right. This is where we are, isn't it? Yeah. Pop you back over here. I'll do. We are on main. Dev branch does still exist. Fantastic. We might be transferring back onto dev branch today, but I doubt it. Alright, so we are on main. It says here. Right, we have our vertex buffer, we have our material. It's a very simple material. Yeah, you could call it colour material. So to generate a colour material, we would just make one of these and assign a colour to this variable. That would then be, we could then insert it here, and we could use this to construct a vertex buffer from data loaded up by assemp. We're starting to see a system. This is the fallout part for the systems analysis person, who's me. I'm that person. I'm not the programmer. I'm not the person who knows computer science inside and out. I am a systems analyst. That's what I do. That's what I'm good at. It's the only thing I'm good at. And we've just spotted a system. So let's see if I can put that into words. That's the first thing. You've just spotted something. So we can decide upon a material. A material design to use. This is programming, by the way. This stuff here is code. This is programming. We can decide upon a material design to use. This can be inserted into the vertex buffer and data can be populated from a file for the 3D model. Notice the language, because there's now the gold code standard. Once we have done that, we have got the gold code standard. Why? Because we have decided upon a material to use for this, to use for this in individual, yeah, model. This is per model. Get it? This is not per program. This is dynamic. So this is a dynamic system for loading models. This is what we're actually coming up with. Just on the spur of the moment. I've never done this before in Qt. I've never done it this way before in Qt, and I've never guarded my material like this before in Qt. And I bet Qt 3D doesn't guard it either. Although they are using the same principles, I haven't looked at the source code. It'd be interesting to see what their buffer actually looks like. But I'm not going to, because Qt offer me nothing in return for this free advertising they get from me. So, stuff them. Told you I don't like people. And that's why. Businesses want stuff for free. They're not willing to give anything out. And the reason they will give for not helping me out for this free advertising is that then they would have to help everybody that streamed Qt. If they set a precedent, they then cannot show favoritism. And that's the business model and the mentality of business. Bollocks to you. Bollocks to you, Qt, for being idiots. Would I advise anybody ever spends money on Qt? No. Would I advise anybody to use Qt Community for learning and development of ideas? Yes. Would I ever approach the Qt team for any help, aid, or ideas on how to make Qt better? No. They burnt that bridge. Because they became a business. Qt started off as an open source community. They became a business. They burnt that bridge at that point with me. If they'd stayed as an open source community, I would help them out free. I wouldn't blink an eye. Programming is knowledge. In business, knowledge is power. That's not the way the world should be. But it is. And tough. I've got to cope with that. So, I digress. We've now just spotted that we have a dynamic system for loading 3D models. Nowhere in here have I put async. Why? Because to do so would be stupid. To put async into your well, this is going, by the way, into, oh god, yeah, it is, isn't it? Namespace night. Well done for remembering. This is going into namespace night, which means it's going to be part of the midnight structure. I'm just using namespace night because it's supposedly simple for me to type. So let's pop it in there. So we're going to be making this into part of our static library. So how complicated was that? Well, if you look at the code, not complicated at all. If you think about the code, it's unfortunately too complicated for the human being to understand. And should be. Because we don't work like computers. If you do understand the ramifications of what we've just written, and you do understand all of the implications of what has just been written, you're on the wrong planet. There's no way you can. You could spend a lifetime studying this piece of code and never, ever find the answer to this dangling material, because you can't. Computers aren't designed that way. Just a word of warning, you cannot program memory. And I'm going to keep repeating that until people actually work it out. Stop using databases. Databases are an attempt to program memory. They all are bugged. 100%. If you want a secure piece of software, an application that is 100% secure, you cannot use a database. That was my security warning for today. I should do government health warnings, shouldn't I? Maybe. I wonder how far my insanity goes. So, we know what the system is now. We've now got a base system design. This becomes remarkable. Mind you, they do say that there is a fine edge between insanity and genius. I'm certainly not a genius. Oh dear. We must adhere to this. If we don't, we are going to fail. Right. There's only one way forwards. We have to write a program to adhere to this. We can't as a human, but a computer can. If we try and program any of this, we're going to fail. But a computer can do this. It can program this. Now that's interesting. We'll have to tell the computer how to program this. We're going to need a data converter. We can't have the data coming through ASIMP. It's not going to work. Because ASIMP uses memory. To store the data in and then transfer the data. We can't do that. We have to take the data direct into the buffer. It's the only way that we can sidestep all of those oopsies, those bugs. Because I have every belief in the world that ASIMP is bugged. I have every belief in the world that this operating system I am using is bugged. The only way we can get past those bugs and get gold code, non-bugged, 100% reliable code, is by sidestepping the whole bloody lot. And we can do that because we have a computer that can do it for us. Right, you little SOB. We're going to war. We have a renderer. Not sure I want to use Vulkan widget to do this. We can do, can't we? We can keep extending this. But not on main. Alright, we've got to stop programming on main. Otherwise we're going to get into trouble. I'll put this up. This is finished. This is gold code. It's a single pass gold code. Because it doesn't do anything. Yeah, this breaks the rule of 3. We're sidestepping. Alright, I'm happy with that. You can have this. What's this? What are we actually doing? We are doing a Vertex graphics, GFX, Vertex buffer. Single pass gold code, as it doesn't change a thing. There's no actual change in any variable. There's no assignments. There's no loops. There's no programming, basically. Single pass gold code for developing buffers. There we go. I think I've talked about programming before. Programming is 3 things. Assignment, decision, and loop. You can only do 3 things in programming, and we have done none of those in here. There's no assignments, there's no decisions, and there's no loops. This is not programming. Right, so I've got that done. Let's get that up on GitHub for you. It's just pure gold code. In fact, the best gold code you can get. And it's bug free. You're saying, hold on a minute, but you're using this. Isn't it? How do you know this is bug free? Because this is exactly the same as that. Yeah. So I haven't actually used anything that could be bugged. And that's why I'm happy with it. Straight off. You can see me when I'm programming that I will stop. I will I will R about one little word. And it's not the word that's the problem. It's what's happening to that word in the code that is the problem. And I'm looking not at the problem, but the solutions that are available to us under the systems designed for computers today. And you have to be very careful when you start thinking about things like that. Alright, it's up. It should be ready for us. 2 minutes ago, Vulkan widget. Graphics, buffers. Alright, there's your code. It's on the internet. A dynamic system for loading 3D models. Who decides upon a material design to use for the individual model? Who makes that decision? Does the model make the decision? Does the user make the decision? Does the operating system make the decision? Does your graphics card make the decision? Does Vulkan make the decision? How many systems can make that decision? Do we, as a programmer, make that decision? That's even outside of the computer. But it's imperative that that decision is made. Otherwise, this will fail. And it has to be one of the first things that we do. Now, the material design itself has got nothing to do with the data. The data doesn't know what it is, so the data we can do. I think we need to look at Vulkan, get a hint on what data it wants. Okay, let's look at that next. Alright, so we've done some code. Okay. Alright, let's run a piece of code. There you go. Vulkan. Hello triangle. It's a model. It's got 3 vertices. Each one has an individual color. And using the graphics card and running 2 programs on there, in fact, one will be a fragment shader. One will be a vertex shader. The vertex shader is run first. The vertex shader will decide where the position of these 3 are on screen. The fragment shader will decide upon the colors, and the rasterization will interpolate all of the in-between colors using some form of blending. Thank you, phone. That was loud. That's how that's working, just from looking at the output. Now, they had to follow exactly the same rules that we've just had to follow to get a buffer. Let's have a look, see what we've got. There we go. And they've got it right. Their vertex data holds a position. Whoops, don't do that. What's this pan doing? It holds this, which is a position, but it's only two-dimensional. As you could see, that triangle was very flat. It wasn't three-dimensional. It holds this, which is an RGB for red, green, blue. So let's take a closer look at that. And just pop you out of the way. A sec. We'll pop you down here. So red is 0, 0, 5. 0 is the center, 0, 5 is up. Red. Good. Green. -5, -5. So -5 is to the left halfway. -5 is down halfway. And it's green. The fact that it's rotating doesn't help me explain this. 5 -5 is RGB, blue. So that is 5 to the right in the x direction. 0.5 down, and that should work out to be blue right now. And because it's rotating, these two positions are swapping. The fixed position being the top, as that is the axis of rotation, which is the y-axis. If we check, there will be a piece of code in here that says you are changing the y-axis. +1. X, Y, Z. They're changing the y-axis. They are rotating around the y-axis. It says it here. Right, okay. Things seem simple, practical, understandable. And note that the vertex data and the projection matrix, which we are not doing at the moment, assume OpenGL. With Vulkan, Y is negated in clip space. So Y is negated. And the near and far plane is at 0, 1 instead of -1 to 1, which it is in OpenGL. These will be corrected for by an extra transformation when calculating the model view projection matrix. We will probably not have to do that because we'll be working in Vulkan. But this is what I wanted to see. We've just defined that. That is a vertex. Position and colour. No material. But it's a start. Position, colour, no material. So it's just missing the material here. But that's exactly what it is. They have placed this on the... They placed this in memory. I nearly said the stack. It isn't. That's a pointer. If you don't know, the name of an array in C and C++ is a pointer. It's a pointer to a memory address, which can, or a set of memory addresses, I should say. It's a buffer. That's an assignment. That's a buffer. That's exactly what we've just designed. It just looks different, that's all. For some reason they want to know the uniform data size. There are 16 pieces of information here, and they are all the byte size of a float. So they're storing that information. We could store this within the buffer. That would be bad. Okay. That's an external reference, which is also bad. We don't need to store that, because we have size of buffer available to us. Remember, I made it a type def. So, just like float is a type, our buffer is a type. So we can use C's functionality, and well, it's C functionality, the size of command, which is one of the 15 commands you do actually get in the programming language, to find out how big it is in bytes. Bits, bytes, bits, bytes, bits. I think it's bytes. Don't quote me on it. We'd have to look it up. I'm not a programmer. Does it tell me? A float is 4 bytes long, so it's bytes. So somewhere it's going to need the byte size information of our buffer. So basically we could replace this here with our buffer. We can assign the color values and the position values that are given here to that buffer, to that, but we would need 3 of them. And as I said, we don't want 3 vertex buffers, we just want 1. So we're going to have to go back and modify something, aren't we? And this is where it gets confusing, because look at how it's stored. And it's how it's stored that matters. I think I'm going back a few episodes now, or a few streams now, when we were talking about mouse picking, and that we're going to be using our buffers to reference what the mouse is actually hovering over in a 3D scene. Because the GPU has already done all the calculations for us. We already have the information. We're going to be referring back. So we need to know how this is structured, how our data is being entered. Our data is being entered linear. So color, position, color, material. Position, colour, material, position, colour, material, repeat, rinse, and whatever. That complicates things. We should really define a vertex, shouldn't we? We haven't done. So I think that's probably a good idea. Let's do that. So we are going to take the goal code and destroy it. Oh dear. If we write it carefully enough, we're going to get away with this. Alright, we'll try. Alright, so what we need is here. We need a type def. I'm staying with me type defs for now, until proven otherwise. And we are going to call this the GFX Vertex. Now we know what a vertex is. It's not going to be too difficult to do. Why has it just done that on me? No. P off. What's it doing? Why is it formatting things in such a stupid way? Don't. I don't like Qt Creator as an editor, but it's this response stuff that is fantastic. It's a lot better than Visual Code. Visual Studio, its response time and its responsiveness is crap. Qt Creator, however, allows you to previous definition is here. Oh, right. You put buffer in. Use tosspot. I know you're trying to be helpful, but don't. Please. Thank you. It's nothing personal. But you shouldn't be doing that. So what do we put in here? We put our vertex in here, don't we? Now we're starting to cook on gas. Alt, Shift, drag, tab. Alright, so what do we actually have here? We need an infinite available, and this is where it gets very, very confusing. We need an infinite available space of memory, area of memory, to fit as much data into as we actually have. And it has to be dynamic. Yeah. How do we do that? Well, unfortunately, it comes with a price of confusion. We have to use some kind of storage. And the storage that we are going to use is... yeah, you guessed it. How confusing is that? If you are a beginner programmer and you enter a language like Qt and you start seeing QVector used in, well, so many different types of way, from mathematical to storage to buffers to, oh, your brain's going to explode. How do we do QVector anyway? Anybody any ideas? told you I'm not a programmer. I don't remember all of this stuff. Where's the constructor? This is what you can do with this storage class, by the way. An awful lot is the answer. How do we make it? It's a type. It's got to be a type. It's a type T, isn't it? Like QList. Must be. Now we're going to have a bigger problem, aren't we? I think it is. It's just a type. Oh God, look at all this lot. Can't we find a better description of this anywhere? The reason I am looking this up and not just splattering it in is because I don't want to test this. Container classes, there we go. We've got hash, qvector and qlist. Yeah, I thought it was like qlist. My type, yeah. Prior to Qt6, qvector and qlist were separate classes. In Qt6, they are unified. Oh. Qt5 qlist implementation is gone, and both classes uses the updated qvector implementation. Instead, qlist is the class with the actual implementation, and qvector is an alias. It's a type def, as I told you it probably would be. Yeah, but to qlist in this case. Yeah, we can just use qlist, I suppose. That would, I think this is because of the confusion it's causing. So let's swap over to using qlist. But hold on a minute. Did it say it had the same functionality? Because that's the important part. I've just tried reading it. Implementation is gone and both classes use the updated qvector implementation. You beautiful people. It's an alias to qlist. Alrighty. Now we're cooking. We can now stop the confusion by saying that. Isn't that wonderful? Well done, Qt. You must have listened to somebody, because I wasn't going to tell you. I think you spanked it up a little bit there, hadn't you? Making mathematical classes with the same name as your structure classes. Pretty stupid idea, wasn't it? Let's be honest. Let's make a QList of GFX Vertex. And we will call this something in a minute. Where's QList being sent to? That line of code tells me that we've just made a this is good, a resizable area of memory, that's a buffer, on the stack, that's the chip memory, at an unknown address to be assigned to us from the operating system. Holy crap, that's bad. This cannot change size. This can. That's where the star goes. We've done it. We do not want this anywhere near our chip. We don't want it near our CPU at all. People say, oh, but what about the speed? It's faster if you have it there. What is the speed of your computer, by the way? Do you know what speed your computer is running at? I know what speed my computer is running at. I'll show you. Dum, 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 dum. Are you ready to be shocked? My computer is currently running at update 1 gigahertz. 1.5. This computer can run at 5 gigahertz. Well, 4.7. What is the point of me putting it in the CPU cache if my computer isn't even under pressure? It's currently running at 2%. And I'm streaming. Is that going to stay down there? It bloody well is, isn't it? How about Windows, will you stop putting your fecking bar there? I don't want it. Where I put my data is immaterial to the speed of its processing. Yeah, it'll take a few CPU cycles to go and fetch the data. My computer's not under pressure. But what about the 3D graphics? Isn't it going to slow down our 3D graphics? No. Because we'll be loading this Vertex buffer up onto the GPU. Where we store it initially is completely immaterial except for one problem. And remember what the problem is? We've been talking about it enough. I'm trying to ram it home. You don't get taught this in computer science. You don't get taught this in computer programming in today's society. If you are a student and you are watching this, you are not being taught wrong. You're just not being told the truth. So yet again, we have sidestepped the problem by putting a star in front of it. It is not at any point going to, if you want to know what the problem is, you please go back to the previous stream or earlier this stream, and I do recap it at the beginning. I'm just trying to save time. So we've now got this Vertex data safe. It's without bugs. That's the point. There's no bug here. If I take that star off, there's a huge bug. if I don't put that on there, we're screwed. We are in hell. And we'll never find the bug, because we'll never realise it's that damn star that's missing in all of the lines of code that we're going to have. Thousands of lines of code. This is what the difference between Pass 1, Pass 2 and gold code is. The Pass 3 standard gold code. This is gold code. It cannot have a bug. There is nothing here to create a bug. There could officially be an assignment in here. And I think there is. I would need to check that code to make sure that that assignment is from the operating system, and that that assignment is the allocation of the memory address, and that the operating system allocates the memory size. It does, because it's a vector. Yeah, good. Right. That's gold code then. It cannot have a bug in it. It can. You could miss that star. And at that point, you have undefined behavior from your code. And that undefined behavior will happen at the time when you transfer your data to your GPU. God help you from then on out. Because at that point you completely lose control of it. Alright, so we've altered it so that now we have a line of vertex data going across the screen in position normal material. We have those lines now being made into a page of data, where you're writing each line across the page, going down a page, using a queue list. And we now have what we've just seen. In fact, if we were to look at the code behind what we have seen, and the code that is generated behind the scenes for this in assembly language, you would discover it's the same code. The difference between the code is here. We have an iterator attached to ours, which can do things. It can go up and down our data, pull data out, put data in. It can do wonderful, wonderful things. It can do lots of things. It's got masses of functionality. Whereas the way they did it has no functionality whatsoever. And yet I'm saying this is gold code. It's gold code as long as we do not call that functionality. But we are going to have to give a call to that functionality to transfer this to our GPU. But we now have the final buffer. More complicated than their version. I will take that space out, I don't really need it. But this is in C, not C++. Yeah, Qt in C. Yeah. I think that's going to do it. I actually think that will do it. So we are going to use async to load the data. The data gets transferred into a vertex, and each vertex is stored into our buffer. Once the buffer is complete, we can upload that using Vulkan straight onto our graphics card, and at no stage can a bug exist. Because we're going to do something to our data to prevent bugs existing. Okay, let's plan this out. If we don't plan it out, I'll get it wrong and we'll all cry. Alright, let's get off this computer a minute. You'll find that I'm not hiding anything in this Games Club. This is the real way of doing things, not me inventing things. Well, I am actually inventing things. I've never written it like that before. What you have to understand is that every process, every thought, and every single keyboard key that I hit is going to be recorded in this stream. It's all going to be uploaded to YouTube to serve as not educational information, but hopefully helpful information. I'm trying to explain everything, all my thought processes, which is why it's very wordy. And obviously, I'm trying not to splatter code. So we have got to this point. We now have all of this. And we haven't programmed it. Because we decided yesterday you can't program a buffer. Yet we now have it in code. So, let's have a look at the next few steps that we really should be taking. So let's come back here. This is the part that I do. This is the part that I like doing. The programming side of it is just immaterial. It's just a fallout of what I do. As I say, I'm not a programmer. Okay, get rid of that mouse. How do I get rid of that mouse? Can we get that mouse out of the way? Thanks. Okay, I've got the keyboard back. The keyboard's working. Okay, we've got a space. How to develop it's alright, you're allowed to chat, you know. How to develop software. To transfer a 3D model I'm going to be careful again from storage to the GPU with a buffer. All right. This is my job. This is what I have been doing all my life. I can't type very fast, you might have noticed that. That's because my job was never the typing. My job was looking at a blank black screen with a pen in my hand, writing my thoughts down. One. This is going to be interesting. You can see I'm more comfortable in this format, can't you? So, use async to load a model. 2. Test. Display the model. Save the buffer to storage. Use the new buffer for steps 1 and 2. There's my program. There's your system. Why? We don't trust async. So we have to have a test. That means I don't trust you. If the test is successful and we get a result which we can work with, and we can actually get this program through 3 passes to gold standard, which I doubt we can, but we're going to try. We're going to save that resulting buffer that we used to display the model. We're going to save it out to storage binary. I'll put a bin there. In binary format. Because binary format doesn't need converting and can be loaded a lot faster than text. I was originally going to go for text format, I'll be honest with you, because I wanted to be able to allow people to access and change the data directly and easily using a text editor. And then I realized that what they are going to open up is a file full of numbers, which will make no sense to them whatsoever. So we may as well use binary. Now, optional. Models. There's a big reason for that, actually. One that I'm not going to go into here at this point, but it is optional. Once you have done steps 1 to 4 and you have completed that, you can then very easily create a tool that can load up a binary file, a model, modify it visually on screen in an editor. I'm looking at you here, what are you called? Blender. And save it out. We're here. Let's research. We're off. We're going. We're researching. Where I develop any of my 3D models is immaterial. Open a file. Woohoo! What was that behind you? What did you flash? You flashed something. What was it? It was a console. So my eyes are very sensitive to that. Is how I spot virus attacks. Yeah, it was a console. This is a console launched setup. There you go. Here's Blender. Yeah. I'm not worried about viruses. If anybody wants to send me a virus and infect my machine, please do so, but be warned, I will be sending it you back. And I'm not going to promise that I won't modify it. Is that it? Would seem so. Okay. Oh, it's here. I want to have a look at something. Left, play, dark, next. Yeah, okay, whatever. Manuals, credits. Very nice. No pretty picture. Thank you. What I want to look at is this here. What? What? Blender? What are you doing? Okay. I don't need it that size. Christ. This is a 50-inch screen. File. Export. What's missing? Binary. If you save it out normally, you're just going to be saving out a Blender file. Notice you cannot save out a 3D object from Blender into binary. I find that interesting. I thought I'd noticed it a few years ago when I was developing systems for something else. And it twigged in my mind at that point that, hold on a minute, there's something wrong here. What this means is there is no standard binary format for a 3D model. Some of these, by the way, may be in binary, But look at the extensions. There's no .bin. I can't remember what 3DX is. Or X3D. That could be binary. I think DirectX is possibly the closest you're going to get to binary. But there's also something about Blender that's hidden. How do you get to it? Why do you need that? Report a bug. Why do you publish an application that you want people to use and then have an option under help, report a bug? That shows me how much faith you have in your software. Sorry, I just saw it and thought I'd point that out. Ah, preferences, found them. Here we go. Themes, viewport, lights, editing, animation, add-on. Ooh, add-ons. Official community testing. Well, that's not really much more help, is it? It just makes it stupidly big. Let's make it a bit bigger. Oh, it's attached. Alright, let's make it a bit bigger then. I don't need to see Blender whilst I'm doing this. Alright, add-ons. Import, export. I'm looking for a binary exporter. FBX? Possible. .py. Could be. Remember, I don't know off by heart all of these formats. You'd have to look them up. Alright, we've already got those ones loaded. So you could load all of these ones up. I don't know if that worked. Oh, yeah. Alright, we've got a bigger... a nuke. Duke Nukem. Paper model. It's a new one to me. Protein data bank. There's a few new ones in here that I haven't seen before. We do have a .xyz, which is just a list of XYZ coordinates. That's changed. What can we import? Can we just do a generic save as? Let's take the blend off. You put the blend straight back on, you sod. Test. Jurist. Oh, that'll do. No. So I can't do it that way. I want binary. I want to see. Well, what I'm thinking in the back of my mind is, over the next week, especially next week, we are going to be programming the first part of this, and then we're going to do the programming of the saving of our buffer. And once we've saved this buffer, I want to compare it to something. And I was just hoping that Blender might have a way of giving us a binary file of the original object, as well as a Blender file for us to work on and load up using Asimp. And then we could see at the end of everything whether our binary file was the same size as the Blender binary file. Now, wouldn't that be nice if we could do that? It'd be an interesting experiment. Well, let's try a different approach. Here. Thank you, Blender. Interesting. 3D model binary format. GL transmission format binary file is a standardized file format used to share 3D data. glib, GLB. Do we now have that? Yes, we do. GLTF 2.0. Well, as we are going to be designing something along that lines, Binary 3D Graphics Soft GLD Center. Are these the people that actually put it together? No, they've just altered the order. They've tried to... They know that half the programmers in the world are dyslexic, don't they? Alright, so we've decided we are interested. So let's paste you here. Let's see if you've got a wiki. Oh no. That was unnecessary. So it's called GLTF, not GLB. Right. Graphics Language Transmission Format for OpenGL. Right.
GLTF. File name extension. .gltf, .glb. Internet media type. Model GLTF plus JSON, Model GLTF binary. Developed by Chronos Group. Initial release. The latest release.
Is this to get around ASIMP? GLTF runtime 3D asset delivery.
GLTF trademark symbol is a royalty-free specification for the efficient transmission and loading of 3D scenes and models by engines and applications. GLTF minimizes the size of 3D assets and the runtime processing needed to unpack and use them. GLTF defines an extensible, publishing format that streamlines authoring workflows and interactive services by enabling the interoperable use of 3D content across the industry. Updated GLTF 2.0.0 specification now canonical. Chronos has released a new version of the GLTF specification in preparation for submitting GLTF 2.0 as an international standard. The new GLTF 2.0.0 specification does not introduce technical changes that will directly impact existing tools and engines, but it aligns GLTF with the rigorous drafting criteria needed to be accepted as an international standard. The new specification incorporates technical clarifications, bug fixes, and is now authored in the ASCII markup language with the source available under CC BY 4.0 on GitHub for easier community feedback, contributions, and downstream remixing. Read about GLTF's ongoing journey to become an international standard and the updates to the new GLTF 2.0.0 specification. Read the blog. GLTF helping to make 3D pervasive. GLTF is constantly evolving to bring new capabilities and improvements to the file format. Here are some of the most significant developments. July 2021. New GLTF extensions raise the bar on 3D asset visual realism. GLTF can now represent material properties such as refraction, color attenuation, and volumetric properties. Press release. April 2021. Use GLTF with KTX 2.0 to further optimize asset size. Universal distribution of supercompressed GPU textures, open source KTX 2.0 tools and guides released. Press release. December 2020. Wave of new GLTF PBR 3D material capabilities. New physically based rendering extensions for clearcoat, transmission. Clearcoat, transmission, and sheen continue to build a powerful.
So GLTF is a thing. Interesting. What am I on here? I'm on Manjaro, am I? I usually am in Linux. Interesting. I think I am. Okay. Printers, Qt settings. Yeah, it's Manjaro. Okay, that's all I needed to know. Why did you just do that? Windows. Blender is missing compression options when exporting to GLTF. I don't give a toss about compression. You're asking for trouble. And that's probably why it doesn't have them. Update request for packages imported from Arch Linux. No. It's not going to give them. So we'll have to go with AUR, aren't we? Did I mean AUR Golf? No, I didn't, Google. Why would you assume I did? Alright. Package, description. MIT, that's fine then. Sources. Nothing said about it. Why did back arrow not work? Ah, it did. Have we got a date on this? 2021. Last updated, not updated. Okay. Alright, we're going into there again. Okay. Well, this is Kronos Group, who do OpenGL. So we're back to this. Okay, so this seems to be hidden. Use GLTF with KTX2 to further optimize asset size. Don't want to be... I'm not here to optimize. PBR 3D materials, okay. Yeah. Okay, they've got Happy Joy Joy pictures. Fantastic. I'm hoping the kids really enjoy scribbling like that. I know I do. Sample models, drag and drop. A sample viewer. search results. GLTF. QT3D, QT Quick, QT Quick, graphics, Control F, GLTF, phrase not found. Yeah, you gave me a page on it. Yeah, you are inside QT3D. Why have we got wine involved? Okay. You're crying at me. Can't be that late. It says it's got examples, yet it doesn't display them. Okay. Said it was in QT3D, didn't it? Example resources. QT3D examples. Yeah, QT3D example resources. There we go. Assets. Okay, let's take a quick look at you. Oh, it's in QML. Another crap language. So these are accessors, okay. Right, so I don't think Qt is possibly designed this way, which is immaterial. That's okay. And obviously you can already see that we've got problems here with this code. So it's just got numbered accessors. How much of this crap is there? This is a problem with QML. And it's why I don't program in it as well. Hooray! Colada with a Shah. Alright, so it's taking it in from wine bin. JPEGs for textures, maybe? Or buttons to click on. Alright, so we're using instance techniques. That's Vulkan. But they're just naming it that. That is not actually Vulkan. They've got the material indices, material primitive, yeah. That's mesh. That's a class you'll often see in C++. Mesh. Well, we won't need that, will we? Normal position text coordinate, indices, material, and yeah, this is standard OpenGL. Okay, is this usable? Instead of ASEMP? An open registry of tools that create GLTF assets along with structured metadata such as links to documentation and bug trackers. Formats. 3D tiles, an open standard for streaming and rendering massive heterogeneous 3D content. I'm sorry, but I am not a dictionary. I'm sure I just copied that. Maybe not. Right, we'll do it that way. Medical definition. Originating in an outside source. Derived from another species. And they spelt it wrong. Consisting of dissimilar or diverse ingredients or constituents mixed. How does that relate to what the sentence was? An open standard for streaming and rendering massive, mixed 3D content. Got ya. VRM, a 3D avatar format for VR applications. Okay. Using WebGL. Well, that's damned useful to us, isn't it? Could be, actually. Meshes, nodes, that's ASM. Here we go. Scene, node, mesh. Material, texture, image, sampler. Yep, ASM. Camera, skin, animation, accessors. That's why it needed all that garbage. Buffer view, buffer. Which is the bit we want. So we've got scene, node, camera, mesh. We could take the mesh, the material. Mesh, by the way, is your positions and your faces from OpenGL. Your material is what we've discussed we have to develop as we go along. Textures are obvious, they're just pictures from an image. And the sampler should be on your graphics card. Why is it here? We already have a sampler on the graphics card. The texture is defined by a sampler and an image. The sampler defines how the texture image should be placed on the object. That's already given to us on the graphics card. That is hard coded. Why is it here? Material contains parameters that define the appearance of an object. Yeah, we've already realized that, I think. The accessor is used as an abstract source of arbitrary data. It is used by the mesh, skin and animation and provides the geometry data, the skinning parameters, and the time-dependent animation values. Key values. It's used in Qt3D, this, isn't it? The animation system. It refers to buffer view, which is part of a buffer that contains the actual raw binary data. So the raw binary data is in the buffer. And they're using an interface called buffer view to look into that buffer. And I'm guessing that's a double interface. That's the interface. The buffer view is something that collects the data out of the buffer and presents it back to the accessor. Okay, why would we need to do that? What this is saying is it can load and display at the same time. Alright, so they packed the image in. The image is inside this as well, is it? Bad. Yeah. You see, what I'm looking at here is reduce the size of the files so that they may efficiently be transferred over the web. Now, if you remember back to a few things I've said in the past few streams, I have referred to this development as an overlay for your operating system that relies on servers. Actual data, it points to other data, yeah. As an alternative, the data may be embedded into the JSON in binary format by using data, yeah. Right, firstly we've got a JSON file. Okay. Okay, what language are you using here? JSON still? I think you are, aren't you? Now, with this being JSON based, I would say it's web based or designed in that fashion. Yes, it is. This is designed for allowing you to show a 3D model on a web page. Well, well, well. Told you didn't know everything. I wasn't joking. Don't want you open anymore. I've completely just lost interest in that. That's a shame. We could use it instead of ASIMP. How difficult would it be to bend it? What, Poppy? Is it time for what? Oh, I see. An hour to go. Thank you for reminding me. Shall we have a cup of coffee and start winding down? I think that might be a good idea. Let's get the kettle on, shall we? I think we've gone further into this than really I should have done, but do I have a talk for today? Yeah, alright, we'll do a talk. I think we've done enough research. I'll keep that in the back of my mind. We might come back to that stuff. Yes, Poppy, I'm going downstairs to put the kettle on. Come on. What's wrong with you? Alright, what's today's talk going to be? Let's get out of research mode. Got anything else in here? No, I'll stay on research then. It's okay. Today's talk, we've done some programming, we've done a hell of a lot of research into what we need next week. Tomorrow is just a talk, so I wasn't going to do one today. I haven't prepared one. So if you've got any questions, now's your time to ask whilst I'm making me cup of coffee and get them into chat so I can read them when I get back. Otherwise, I'm just going to do a talk. A spontaneous one on a subject. Right. Have I done the internet talk yet? I don't think I have. That could be interesting. Alright. It's alright, these talks aren't public. So you will be hearing them for the first time. That's going to be interesting. The reaction from the industry so far has I'm having to refuse and turn down jobs. Yes, I know that. And other things are coming through that I'm having to turn down. I want this to be free of charge. I am accepting no money, no donations for anything I talk about, and I don't want anything in return. If there is a subject you want me to talk about, I will do so, and I will keep it truthful, and I will tell you if I don't know. better warn you, if I do choose a subject, it's going to be a subject close to my own heart. What have we got on here? Okay, we've got the Vulkan stuff done. Buffer system, buffer for games, the Vulkan Vertex buffer. We've actually designed it all today, which I wasn't expecting to get done. We are staying with our simp at the moment. We have not decided to change to anything else. We have looked. We could, at a moment's notice, if somebody turns around on my chat channel and says, no, use this, then I will. What I use is immaterial. Asim just happens to be on Manjaro and downloadable, so. And I've also got some notes on it. Right, let's not mess the board up. Let's close the board. Let's close you. Actually, this is very interesting, and I'm going to use this as a premise to do a talk about what this means to me. So I'm going to keep that open, because it shows everything that I want to talk about, possibly. You've literally got about 1 minute left. No, 2 minutes left before I start this, so. We should really give it a title, but I don't have a whiteboard for this kind of thing. Should I have a whiteboard for this side? Okay. Talks. We'll have. Done. What's today's subject? Nothing in chat, so. Where are we? 26th of March. You have to put that. you have to date this talk, because obviously it changes. Right, just give me a second. Okay, this is just a random talk. It's got nothing to do with what we've been doing today. It's completely off topic, and I'm doing that on purpose. If people are interested in the title, then they will continue to watch. Otherwise, go on to your next video and watch what I do with the buffer. Okay, that being said, this is a talk by me, Blades, the cantankerous old git. I think we should have that in brackets by now. The state of the internet today. 26th of March 2022. So, the first thing we need to know to put this into context is, when did the internet begin? How the hell would I know? Right, let's find out. Let's type in your research. No, internet wiki.
In the 1960s, the Advanced Research Projects Agency, ARPA, of the United States Department of Defense funded research into time-sharing of computers. 14, 15, 16, research into packet switching, one of the fundamental Internet technologies, started in the work of Paul Barron in the early 1960s and, independently, Donald Davies in 1965. 1. 17. After the Symposium on Operating Systems Principles in 1967, packet switching from the proposed NPL network was incorporated into the design for the ARPANET. And other resource-sharing networks such as the Merit Network and Cyclades, which were developed in the late 1960s and early 1970s. 18. ARPANET development began with 2 network nodes which were interconnected between the Network Measurement Center at the University of California, Los Angeles, UCLA, Henry Samu.
Right. The 1960s is where it all began. Does it go through to the protocol? 1982, the Internet Protocol Suite TCP and IP was standardized. So the internet became live in 1982. Is the best I can give you on. I'm giving 1992, but 1982 was the first. It wasn't the internet, but it was a network, and it was initially designed to connect all of the universities within America and over to Europe for information interchange. And that's why it's called the internet. It is something, it was a communications device to help research and the study at a university level of academic, a higher level in academia. It was never meant for the public. Initially. It did become public, and I think that's in 1990 area. Let's just see if we can get a public on this. HTML, there we go, web browsers. When was that done? Because remember, it was, well, previous, I suppose, it was BSD, wasn't it? Which was just bulletin boards and stuff like that were being used to interchange information between people. So we are looking at HTTPs 95, 96, Windows 95. Isn't that coincidental, do you think? Remember, before Windows 95, 1995, we were on Windows 3. Or 3-point junk. There we go. 1990, the tools were built. So that gives you an introduction to how the internet started. It took from 1960s to 1995, 35 years, to come from a basic premise of information interchange, which then became, it was designed for on a Unix system for the American military originally. This is where all the research came from. And it was through that research that Unix came about, and the story behind the servers for the internet is that they are Linux based, mainly because this is a Unix system. The internet is a Unix system. Unix was designed for programs to talk to each other. And when you extend those protocols to computers talking to each other, you get the internet. So if anybody has just understood what I've just said, there is a separate talk on that. Unix. What happened? Why aren't we using it? Why have we lost those capabilities? Have we lost those capabilities? Do programs talk to each other? No, they don't. We use microservers for services. Just have a look at your Windows. So you actually have a copy of the internet on your operating system. Did you know that? Let's have a look at it. 35 years to go from the base ideas. We've got extra mice here again. To go from base ideas into a fully functional, by 1995, a fully functional World Wide Web, which actually came about in 2011, if my memory reserves correct. Don't quote me on that one, haven't looked it up, but it's probably down the page someplace. Now, one of the problems with the internet is there is no ownership. The space it occupies is virtual, and it can cross any boundary geologically. It is an entity within its own right, and nobody can govern it. You can start seeing some problems here already. Okay, that was interesting. This talk is about the state of the internet today, but I needed to present you with the initial foundation of 1995, which was 27 years ago. We have another, let's see, 27, 8 years before what happens next. Remember I said it took 35 years to get from the initial ideas of Unix into the internet? Well, the ideas of the internet going into what it's about to become, I would estimate would take about 35 years. Well, actually, I know it's going to take about 35 years, and that in 7 years' time, something is going to happen. Is it something I'm looking forward to? Possibly. I haven't made up my mind about what the internet is about to become. And I don't think anybody today has even thought about it. Except for the people who are working on what it's going to become. Because when you have a free, available resource like the internet, and the biggest business in the world today is advertising, who is designing the internet of tomorrow? Is it us programmers? Have we even thought about it? Do we take the internet for granted? Well, yes, we do. We take the internet for granted. We don't care what's going on behind the scenes. We don't care about all of those servers and how many connections it takes to get from A to B. We don't care about that routing, those pings, those pongs. We lost all of that in 1995 due to a program called Windows. I said we'd look at that, didn't I? Task Manager, isn't it? There we go. Here it is. Comes up with this nice little thing, but there's more details. Oh yes. Services. Oh yes. That's the internet. Servers give you services. On your Windows machine has microservers giving services. And that is how the communications around your computer are done. In exactly the same way as the internet. But, let's just enlarge this, it's ridiculous. Yeah. PID, P-I-D. The reference to a running server. It's how they do memory management as well. Can we just think? Yeah, we can. Good. Alright. Can you see there's a couple going at the moment? Yeah? That's the open services that are currently running on my machine. Okay. Let's see, processes. It's under performance I'm looking. 110,300, and they are being dropped and picked up all the time. They are being created and destroyed all the time. Each one of these handles is a reference to a service. There are currently 3,300 threads running on this machine. Each one of these threads is a single thread running through a service, like the mouse. The mouse is a service. And on those threads it has the handles used for that service, because that service may need other services. So there's a change of information via handles, which we've talked about before with the GPU and graphics programming. Oh, I'm up to 3.97 gigahertz all of a sudden. I wonder why that is. Maybe because I'm looking at things we're not supposed to look at or understand. You're looking at the internet in the format of an operating system. The operating system is not Windows. Windows is a microcosmic internet of services running on top of an operating system. Your operating system is not shown here. Where's your operating system? Microsoft, where have you hidden it? Under Windows? Ah, there it is. There's your operating system. Windows PowerShell help system. Why am I in PowerShell? Can I be in CMD? Quit. Thank you. CMD. Thank you, help. PowerShell isn't your operating system. There's your operating system. We found it. It was hiding in CMD. Trying to get away from me. Well, I'm sorry, but you can't do that, Windows. You can't hide from me. There's your operating system. Your operating system has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 30, 40, 50, 60, about 60 commands on it. That operating system was written when? This is what, when you buy an operating system, this is what you're buying. You're not buying Windows. Windows isn't an operating system. It's an overlay. The operating system is those 60 commands. I digress. The state of the internet today is in exactly the same state as it was in 2011. Years ago. There is no politics on the internet. There is no control. There's no ownership. Yet. What's going to happen? Do you honestly believe that this button here will look like this in 8 years' time? Look at it all. Information. This is the state of the internet today. By the way, this page doesn't end, I don't think. No, it doesn't end. When it gets to the bottom, it just loads up the next bit. I can carry on going until my cookies are full. That's scary, isn't it? Alright, this has got adverts on this page. Can we go somewhere that doesn't have adverts on, please? Anywhere? Why is my change? This has changed. Get off my screen. Oh, I didn't want to close that one. I wanted to say something about it. Never mind. Why have you changed my screen, you little sods? You have done that without my authority. I hate you, Windows. Right, let's have a look at this, the real state of the internet today, shall we? I'm going to show you it. It's here. That's it. That's the internet today. In one massive information dump out to you. This, in front of you right now on the screen, is the state of the internet today. What is Google? It's an advertising company. It advertises. It's not a search engine. It never was. No. Incorrect. It was originally designed to be a search engine, to be very helpful to people who wanted to find things on the internet. It became the biggest advertising magnet in the world. What is Google currently doing? If you look in the bottom left-hand corner, it gives it away. Advertising, business, how search works. That means that Google is an advertising business that knows how to work. It tells you on the page. That is what the internet is today. That is the current state. It is not a network for information interchange any longer at this point in time. It is an advertising medium. Just like a billboard, just like a TV advert. It is nothing more. People will claim that I'm wrong. People will say, but no, universities are still using it. No, all of these, there's libraries now on the internet. There's all of this information. Yeah? But who's interested in it? Who's interested in all of this data? You? Me? Google isn't interested in all of that information. Google couldn't give a toss about that information. Let's have a look at about. Our mission is to organize the world's information and make it universally accessible and useful, and to advertise on it. Oh, they forgot the last bit. Sorry, Google, I added that. You really need to put your mission into the truth. Oh, we've got Google in the UK. Commitments. Committed to significantly improving. Okay, they can't speak English. The lives of as many people as possible by advertising to them. Protecting users so that we can advertise correctly the correct things to the correct people. I'm not being obtuse about this. I'm not even trying to be nasty to Google. I applaud them for what they've done. I think this is a fantastic business model. And a bloody successful one. Google isn't interested. Learn more about responsible AI. Expanding opportunity. Google, what are you actually doing? Google.org. Sustainability, crisis response, diversity, inclusion, accessibility, transparency, digital well-being, safety centre and human rights. How our business works. Do we dare click on that and let me see that? I don't think we should. I'm not going to have a go at Google for being successful. I think that that is the wrong way to approach this. I think we should not be looking at what Google has been successful at, But what Google is going to do with that success? Remember, they have no power in this environment. I've got the power. I've got the X button at the top here that switches it off. Alright? Careers. Software engineer in Los Angeles. Cloud engineering. This is what Google is doing. C jobs. Data centers. This is what Google is doing. They know what is going to happen. Software engineers. Why are they interested in software engineers as an advertising business? Why are they interested in cloud engineering, remote roles, data centers, engineering and tech? There's a big area of sales, service and support, obviously, because they're an advertising company. Consumer hardware. View all teams. Ooh. Here we go. This is what they're really up to. Now we've dug into it. This is the future of the internet. The state of the internet today is advertising. The future of the internet is all of these things here. I'll let that sink in a little bit, because what does this mean, and why would an advertising business really be interested in all of this? There's a rule in advertising. The idea of the internet being an information interchange became secondary. I can tell you when it became secondary. I can give you the date. Where can we get the date from? Here we go. This is funny. It's here. On the 4th of September 1998 was the first day in which the internet stopped being the network for information interchange and began and became the biggest advertising network in the world. It happened in 1998. Because of this change, the internet had to be upgraded. And that happened in 2011, if my memory serves me right. I'm still not checking that. Don't quote me on it. I could be wrong on that fact. So up until 1998... it was information, where it gets its name from, internet. Information interchange. The worst part about this is, after 1998, it's advertising. And quite rightly so. Is this a bad thing? No, I have no idea. That's not what the talk's about. Whether it's a good thing or a bad thing is immaterial to me. I don't really care. The fact is, What happens... When is that? When does it happen? We're in 2022, aren't we? So it's 5. It's 2030. Sugar. It's getting close. It actually scares me. Stop being scared. I've got to collect myself together. I've just scared myself. I haven't known fear in my life. So we are now in 2022. To 95 was 35 years. It happens in 30. Shit. It is 8 years. Something happens here. Again, is it a good thing or a bad thing that something happens? I'm not a prophet. I'm not prophesizing this. This is somebody's plan. This is their set down plan for what is going to happen. This is a big business plan. Because in advertising, you can only be successful advertising. To be successful, and this goes for business as well. Stay ahead of the game. The first rule of business. Well, no, the first rule of business is to get ahead of the game. The second rule of business is to stay ahead of the game. Let's be honest. I'm trying to be truthful with you. The state of the internet today is in a position where we are coming to the end of its second evolution. And when we come to the end of its second evolution, we are going to have the internet of tomorrow. Now you know what the state of the internet is today. I'm not allowed, I can't be a prophet. I'm not going to tell you what the internet of tomorrow is going to be, even though I do know what it's going to be. Is it going to be a good thing or a bad thing? Is advertising a good thing or a bad thing? Advertising isn't either. Advertising is possibly one of the most neutral things in the universe right now. You don't go to war over advertising. You go to war over religion. Actually, only ever religion. I don't think people have ever gone to war over anything else, but that's me just diverging. What did you think the internet was? What do you think the internet is today? Am I right? Am I wrong? Have I hit the nail on the head? Or have I hit the hammer on the nail? Do you want me to be wrong? how does this affect you? I know how it affects me. It doesn't. Because I grew up in before advertising became what it is today. I've seen advertising being developed over the course of a few years, shall we say. And the one thing it's never done is it's never become intrusive. You always have, with advertising, that little button up in the top right hand corner. You, as the individual, have the off button. Therefore, this is not malicious. It's only malicious to people who can't think for themselves or are susceptible to not realising that button is there. And those people exist in our society. Advertising knows they exist, and it's not advertising that prey upon those people, unfortunately. If that were the case, I would now be screaming and shouting bloody blue murder. Don't blame the advertisers for that. That's a different can of worms. Advertising is presenting somebody with a choice, take it or leave it. That is the business plan. You cannot maliciously advertise, because by doing so will impair your advertisement, which devalues it and in fact inverts the value of it. The way to successfully advertise is to be open, upfront and truthful. This then starts a ball rolling, which means your advertising works. If you are deceitful, malicious, or intentionally trying to mislead, you will start a ball rolling the other way. People will rebel against it. You cannot do that. You cannot scam in advertising, because by doing so, you will cease to exist as an advertiser. Do you understand why I don't say this is a bad thing? I think the internet is in very good hands. Maybe not scrupulous hands currently, but I think it's in very good hands. I think it's with the right people who understand the morality of what will kill them. Their future, their money, the thing that business cares about. Currently, on the internet today, is in the right hands. It's with a bunch of people who care about being truthful. It's with possibly I can't say what I was about to say because it involves morality, and morality is subjective and not truthful. So I will avoid saying what I was about to say. But I hope you are now aware that the state of the internet today is in a good place. I'm supposed to say but, and I'm not going to, because there isn't a but. It is in a good place. People use it every day. If it was in a bad place, people wouldn't use it. There is a secondary part to this. And that secondary part is what has changed on the internet since 1998? 95, sorry. That's what I was missing there. I knew I was missing something on this board. What has changed on the internet? If I was to press this button in 1995, what would I see on my computer? I know what I see today. Do you want the big news? I saw exactly the same thing in 1995. Okay, there were a few less pretty pictures and the graphics and the resolution wasn't as high. And a lot of these weren't moving. But it's the same bloody screen. A bar at the top. A search. A way to search. Less advertising in 1995. We were still on the information interchange. There was more information on how to attain information of your choosing, rather than giving us the latest news. Which is completely useless to me, because the latest news means nothing to me. It's the same page. Look. In 1995, start that one again. In 1998, a company started up with a search engine. That search engine was this web page. This web page has never changed and has no adverts on it. Over the years, they have tried placing adverts onto this page. Some of you may get a banner. An interesting banner, but it's not an advert. This page has been kept clean for a reason. Because this page represents what the internet is today. It represents what the internet was and has become. And now I'm going to give the crashing news of the negative side of what has happened. There has been no development whatsoever into the internet itself. We've gained more bits. We went from 8-bit to 16-bit to 32-bit to 64-bit. We are going up to 128-bit. I told you something's going to be happening within the next few years. We are going up to 128-bit computers. The x64 architecture is going to be surpassed. The internet will need its next upgrade. The reason what happened back in 2010, 2011 is the internet had an upgrade. It was upgraded from 32-bit to 64-bit. IPv6 came out and was integrated into all servers. That's what has happened. That's the only change. It was an upgrade due to the technology being able to do more. They were also running out of internet numbers, website addresses. So IPv6 was invented because they were running scared that they were actually going to run out of numbers. The internet address is finite, and it was infinitely growing at the time. This is no longer the case. IPv6 has not taken over. We are not using it. If you check your modem, it is using IPv4, which is the 32-bit version. Why? Why did we go to all of that trouble to upgrade and then not use it? What happened? What happened is nobody took ownership. What happened is nobody ever thought to develop this page. The internet visually is stagnant. But what about all those UI programs and all this JavaScript stuff and all of this programming stuff that you can now do, which is fantastic. You make your own websites and everything like that. They're all 2D. They are all iterations on what you can see in front of you. That. There's the code. It's been there since 1998. It hasn't changed much. It does look different. They have actually cleaned the code up and made it, I wouldn't say readable, but that's it. That's a blank page. A lot of this blank page is to do with hacking, because people want to try and hack Google because they are offended by Google. They think Google's got too big for its own boots, not realising that Google has no ownership over the internet at all. What they're really attacking is their own insecurity, because they don't realise that the internet's in good hands. It could have been worse, couldn't it? It could have ended up in the hands of a government. But instead, it ended up in nobody's hands. And that's why it survived. Google knew that. Whoever was at Google really knew that. For a blank page, it's got a lot of code, don't you think? I think I could do a blank page with less code and access a search engine. But hell, they do get attacked. And rightfully so. They should. They put their head on the block. They should get the attack. That's what it draws. If you're interested in what that code does, I'll go through it one day. I'll explain that code line by line, exactly what it's doing, and we can have a look and see how it's more of protection rather than usability. Ironically. A lot of people say that the internet is now a hacker's paradise. Well, it was a hacker's paradise back in 1995. Don't you worry about it. Nothing's changed. In fact, the internet has not changed. There's my verdict. That is the state of the internet today. And that is my verdict. The people behind the internet, these advertising agencies, the people who pay for it all. Yeah, you have to pay for it, you know. It uses electricity. It doesn't just come free of charge. Do you pay for it? Yeah, of course you do. You pay to an IP holder. I pay Virgin Media. They give me a cable which runs into my house and attaches me to the internet. But they don't own the internet. And what about of all of these servers? Remember, that's just to link us to the internet. What about all of these servers that are privately owned, like universities, libraries, government? Who's paying for them? Where's this money coming from? It's not coming from us. We're not paying for them. We're not paying for the internet. The internet isn't us connecting to it. The internet carries on when we switch off. And there are a lot of servers. Who's paying for it all? Who pays for the internet? And there's an irony in this. The world pays for the internet. It's not owned. It is a shared cost across everybody that has access to the internet or owns a part of it. It's a community. The community pays for the internet. There's nobody out there to charge us for using the internet. We are charged for connecting to it and becoming part of that community. But that charge is a minuscule part of the cost. It's the biggest community business model ever invented? Because it wasn't invented, it just happened. And it happened because it was designed initially to be the free interchange of information, which is the word I left off at the beginning, didn't I? It was designed from something called FreeBSD. And if you want to look up FreeBSD, you can look up all of the prelude to the internet and find out the foundations upon how the internet became what it is today and why it doesn't change. It's changed in its meaning, but the internet hasn't changed. What happens to things that don't change in business? What happens to things that don't adapt in evolution? They go out of date, they die, they disappear. In reality, remember, this is not in reality, this is a virtual reality. So the laws of physics do not apply. But in the laws of physics, in reality, there is no status quo. Everything in reality changes from nanosecond to nanosecond. Everything on the internet changes from nanosecond to nanosecond. Yet the internet itself remains unchanged. It's a paradox. From a scientist's point of view, the internet is a paradox. It should not be able to exist. It should not be able to survive. It should not be able to thrive, expand, or become something. But it has. Don't be concerned about 2030, what's going to be happen, what will happen. Because the internet has become something that no one person can change. No industry is big enough to be able to pay for the internet. So nobody can actually now own it. And if they tried to, another internet would spring up. Wouldn't it? You can duplicate the internet. It's not hard to do. You just get a load of servers, put them together and stick on the services. And you got an internet, just like that. So it can't be changed now, can it? Yet. And yet, it will evolve. And that's the paradox of the internet. Will it be in good hands? Remains to be seen. I'm hoping it stays with the advertisers. I'm happy with them. I don't want it to become government, although that has already been threatened. Mainly on the Pentagon side rather than the Russian side or Chinese side. It has been the US that has threatened to go down that route because the US has in place a way of doing it. If you don't know, in the United States of America, if you live in a state, there is only one internet provider. You do not have a choice. Which is ironic. Each state goes out to all internet providers and says, we would like you to propose the internet service for our state and how much it is going to cost us and our citizens. They then choose the cheapest deal. That goes into place, And everybody in that state gets that internet. They say it's a good system. I think I'll keep my mouth shut. Who am I to judge the Americans? Christ, they can't even judge themselves. I think that really wraps it up. Did I do well? I hope I've proved, or at least given you enough information that and showed you that you can follow this up, to do your own research if need be, and that I'm not just taking this off the top of my head. This is a few years of experience with the internet, actually, since pre-1995, actually. I was around pre-then, doing things on dial-up before the internet became a thing. But that's beside the point. Now, I'd like to hear if the people have stopped by for this talk at the end of one of my sessions, streams. If people do stop by this talk and want to comment below on YouTube or back to me in chat here on Twitch, if you think I'm wrong in any way, please say so. Will not be offended in any way, shape or form. In fact, I hope I'm not going to be right about what I'm thinking about 2030. If I am right, and I am a prophet, then God help me. I hope I'm wrong. On that note, it's food time. The cat cried enough. It's 17:15. We've talked about this long enough. I've done a board page. That's enough. Sorry, board. It's a very, very close to my heart subject because I'm disabled, and the only outside contact I have is via the internet. My food is delivered. I'm lucky because I don't like humans and I don't really crave for human company, although I'm married. Unfortunately, my wife isn't here at the moment. She's in a nursing home. Nobody thought to put her on the internet. I tried. I did try. That is, I think, the basic talk. Done. It might give you food for thought. It might actually trigger something in the back of your mind saying, why don't I care about the internet? And how did I know that you didn't care about the internet? It works. I use it. Why should I care? It's a bit like your bank, isn't it? You don't care about your bank until something goes wrong and your money isn't there. Then you care about your bank. Then you go and talk to them. You don't talk to them every day, do you? They hold your life in their hands. All of your money. And you practically ignore them, don't you? But that's a different talk. That is the state of the human mentality today, I suppose. I would call that one. Brush, please, thank you. Yes, I like that one. That talk works. I've said what I wanted to say, but I've also told you the truth. I have not done anything outside of that. I've stuck to the facts as much as I can, or on the spur of the moment do so without doing a full research into dates, times, and all that kind of garbage. I've tried to keep it as factual as possible. If there are any facts that I have misrepresented within this talk, you can put that in the comments below there on YouTube. If you're wondering where to go, just pop over to YouTube at Fraser Sharp here, and you will be able to find this in programming games, which is where everything is going at the moment. This isn't deleted, it's just not uploaded fully yet. Today's stream will be uploaded tomorrow. Tomorrow we are doing a talk on games. I'm hoping not to do any programming tomorrow, but we may do. With me, I'm a bit random. So you can find all of this if you want it. So it's all here. There's tons of information about different things as well. And I don't think that's got any sound on it. No, it's got no bloody sound on it. Twitch, you are stupid. I've tried getting sound out of it, I can't. Alright, that'll do. That's annoying because that was a really good talk. I'm going to have to do it again. Alright. You know where the information is. There obviously is a GitHub. So, which is on this screen at the moment. Okay, we do have a GitHub available for all the code, which is here at Fraser Blade Sharp Rana is what we are doing currently during the Games Club. I'm only doing this whilst people aren't asking me to do other things. So this is a long-term project which will be built up over the next 2 to 3 years. So Midnight currently is usable and is functional and can be developed from wherever I leave it on main. Do not think you can go over to dev, download that and get an up-to-date. That's not going to happen. What you're going to get in dev is garbage. Stay with main, stay with the gold code. Everything that's on main is golden. It's bug-free. And if you don't change the base code that is given, it will stay bug-free. I will be changing the base code over time, and I will be keeping it bug-free. This is gold code. It's available to you. You can have it free of charge. Catch you later, peeps. Download it. Have some fun with it. Make a game. No reason not to. Take care. And above all, have fun.